Hello everyone and welcome to Power Playground. This is your host Michael, and today I'm going to be showing you all how to make a pegboard spacer, and not only that, I'm going to show you all how to optimize your designs for 3D printing to minimize on wasted filament. So first off, I just want to show you the end product here. This is just a simple pegboard spacer that uses common sizes. I will be using imperial units just because I have an imperial pegboard. However, you can also use metric units, and they're very, very similar. So here's our spacing and sizing here. So the spacing will be that is just the dimension between each individual peg. Alright, so I have a generic picture of a pegboard, which is just a typical square pegboard size. There are some other weird sizes to accommodate that you could accommodate for, but I'm just going to stick to the typical one you can buy from a standard hardware store. Now, this is like a reinforced cardboard or wood, whatever wood pulp thing you want to, whatever the material you want to consider it as, that you can buy at any sort of hardware store. And essentially the spacing in this chart, that I just got this from Wikipedia. I'll go ahead and link the Wikipedia article in the description where you can find this little table here. So the spacing is just between each one of these holes. So as you can see, they're all squared, or they're all equally spaced from each other, which makes this easy. So the spacing is about 1 inch or about 25 millimeter if you want to go metric. Now the actual hole diameter is usually about 1/4 inch or 6 millimeter. Now of course there are some smaller ones, but I haven't seen any that I could find. The most common measurement for these will be about 1/4 inch or 6 millimeter, which are very, very close to each other. So now with our information handy, I'll go ahead and I'm just gonna drag that away. I'm gonna go ahead and create a new document here. Now the first thing we'll want to do in our new document is go over to document settings in the top left browser drop down, and we'll want to expand document settings and go to units. Now currently it is in millimeter, so we'll highlight it, click this change active units. On the right hand menu we'll go ahead and click unit type, and we want to change that to inch. Go ahead and hit OK. I'm not going to set it as default because I don't use inches very often. Then we're going to go ahead and create a sketch. Now it's a little confusing what side you should create your sketch on. It doesn't really matter because you can always flip the model over at 3D printing, but I always like it to be on the right orientation initially so I don't have to flip models over so often. So as you can see, there is a top, front, and right. Now you would think that top would be facing top down, you would be looking down the z-axis, but for some weird reason in Fusion 360 it is that is the y-axis. So pay attention to that. So technically we'll want to be going on the front face instead of the top face, because that will give us the z-axis plane. That's going to be the plane that's going to be facing the bed. So we'll want to go ahead and click that plane once we create our sketch, and then we are going to create our sketch windows. So first off, I'm going to create 2 circles. So I'm just going to put one on the center point, and these circles are going to be our hole diameter, which is about 1/4 inch. So I can just do 0.25 inches, and then I'm going to hit, and of course, to bring up the circle, I usually hit the C key, or you can go to sketch, and then you can go to circle, and then you can do a center diameter circle. But I just use the C key because it's easy. Referencing our spreadsheet here, or sorry, table, the spacing between these holes will be 1 inch. So I'm just going to do 2 holes, and as you can see, we have our measurements lined up here in the green y-axis. So I'm going to go ahead and set it to 1 inch. It should snap there relatively easily with little to no drama. But there we go. So we have our 2 dimensions here. Now, in my initial design, I went ahead and put a bounding box, and I'm going to go ahead and do that again just to make things a little easier on ourselves here. So on each side, I want to go ahead and set a border of about 1/2 inch, and then I want to set these guys. I'm going to just define a measurement of 1 inch, and I'm just clicking the 2 points and hitting the D key to define a diameter between the 2 points, or between the 2 points or line or whatever you're defining them off of. So click this, and then I'm going to hit the control. So you click one dot, hold down the control key, select the other dot or line you want to define the distance between, and sometimes it'll automatically go for the diameter for you if you have 2 lines selected. Sometimes it won't. If it doesn't, just hit the D key and everything will be fine. Okay, so now we have our spacing on the y-axis. Now let's go ahead and do the x-axis now. Now you could do another 1/2 inch. I like to just define this as an inch. That makes things easier when you want to modify these measurements, because sometimes things get a little wonky when you go to define other measurements and or change things around if you don't do it this way. Like for instance, if you just do it from this to this, both 1/2 inch, if you go to edit dimensions, things can get a little wonky. So not always recommended, but it just depends on your personal preference as well as what you're doing. So just always good to think of those types of changes being made. So we have our basic shape available here. So what I'm going to do is I'm going to stop the sketch right now, and then one of these is going to be a solid peg. Well, actually, I'm going to leave them both blank for now. And then we have our spacing between the wall and the pegboard. Now, in my case, I'm going to do 3/4 inch. You might be able to get away with less, but I think that's a pretty nominal spacing. You're going to end up with little to no clearance issues with the pegs hitting the walls, or the back of the pegs hitting the walls. So that is pretty decent here. So we have that basic cutout. As you can see on the original model, I had this spacer peg or more of an alignment peg that just keeps it from wobbling around as the screw gets screwed in, or when it's permanently mounted. And this is going to be an inch off, so 3/4 inch, and then the thickness of our board will be about 1/4 inch. So 3/4 plus 1/4 equals 1 inch. So we'll hit OK, and then just to save a bit of material, and plus to make things just to look a little bit more professional, I'm going to go ahead and fillet these edges here. Now I don't want to fillet the other edges just because that's going to be a support edge, and I don't want to diminish that in any way, and just makes it a little bit more strengthened here. Very minor fillet there, or fillet, or whatever the heck y'all insist I pronounce this thing as. Then once we're done, we'll go ahead and expand the bodies, click our body. Now if there are 2 bodies, you can which sometimes can happen, like for instance if you have one invisible and you extrude the other. Sometimes it just happens where the bodies don't merge together, or whenever you're extruding a new bit off the sketch, it won't automatically join. You can either go back to the sketch and edit it, or go back to the extrude and make sure that the operation is set to join instead of one of the other ones, like cut or intersect or new body. Or you can go ahead and select both bodies, and you should be able to go to modify and then combine. And you can combine. You can also cut from combine, which is kind of counterintuitive, at least mentally, but it's the same it's in the same menu set at least. So at this point, we're going to go ahead and export our model here. So we'll right click our body. In the menu, we'll go to save as STL, and then we'll make sure that refinement is on high, and format should usually be binary. I think ASCII will work as well, but binary is just fine. It'll work. So I already saved that file, but I'm going to show you all the dilemma. Now, with a 4-foot by 2-foot pegboard, which is I think the smallest size you can get, maybe a 4x4, but let's just say you want a 4x2 strip, and you'll probably need about 8 of these. So 4 on each vertical leading edge is usually the nominal amounts. So what we'll do is we'll go ahead and put this in, and then Simplify 3D will give me a prompt that says that this is extremely small and maybe in inches. Would you like to automatically scale to millimeter format? So I'll go ahead and hit yes, and it should automatically scale it to an inches dimension 2 millimeter. Alright, so here is our element now. I'm just keeping the same slicing settings. I have my infill set to 18% and everything is pretty conservative in terms of like perimeter shells and what have you, and retraction and all that good stuff. And I'm probably going to do these with PETG because that is typically the strongest plastic, at least the most durable plastic you can print with. That isn't insanely expensive or insanely complicated. It's one of the more consistent ones for simpler designs like this. Here's our issue. This particular set of prints costs us about 81.76 grams. That is a lot of plastic if you think about it. That is close to 1/10 of a spool. Now say if you had a 4x4 pegboard, you would probably want to print out two times this much, so that would be a little, or yeah, that's going to be quite a bit here. Okay, so 81.76 multiplied by 2, so that is 163.5 grams of plastic. That's going to eat into your costs, especially, I mean, if I were to sell a set like this, I would probably sell it for close to like $8-9 perhaps. I wouldn't really get too much more higher than that. In fact, I'd probably sell a set with twice the amount of little spacers in this just to cover a 4x4 pegboard and just call it a day. Yeah, that would it would definitely be quite a bit, and of course a lot of print time going into that as well. Just so it'd be costing a lot of print time as well as costing a lot of material. So let's try to slim that down a little bit, see if we can reduce the profile on this here. So I'm gonna go ahead and do an arc. So we're back in the sketch. I just double clicked on the sketch in the left hand menu, and then underneath sketch I'm gonna go to arc, and then I'm gonna go to center point arc. We're gonna go ahead and click on the center point, which is our circle here, and then you can do this number. Then I'll go ahead and just do this bad boy here. I want to define that by 1/2 inch. There we go. Now we're within our bounds. And then we'll go ahead and do the same on the other side. We'll of course polish this up here soon. Now as you can see, when I drag this one, things get a little wonky. So what I want to do is I want to click the center point, and I'm going to click the fix button on the right hand side here. Okay, there we go. And then once I do this now, only the arc moves. So I'm going to go ahead and just lock that down to about 1/2 inch. Now there we go, little problem, no big deal, no big deal. I'll go ahead, I guess I'll just have to create a separate arc for the left hand side of these. Not the end of the world. There we go. Okay, so we have 2 arcs, and then what I'm going to do is I'm going to go ahead and go to the line tool. You can either hit the line tool up here or hit L on your keyboard, and then I'm going to click and drag from one point to the other, and then do the same on the other side. Now in order to make these a little bit more even, I'm going to click this arc, which I just created with the line tool, and then I'm going to click the other arc I made, and then I'm going to click on tangent, and that's going to make things look a little bit, the transition between those 2 arcs, a little bit smoother on that end. I'm going to make these as small as possible. Hey, there we go. Okay, so yeah, sometimes you have to fiddle around with that a bit. So we have our basic shape here now. Now we'll go ahead and go out of our sketch. We'll go to the original extrude, and then we will exclude these sides. Easy as that. So all I'm really doing is just holding on Control and then clicking each individual edge that we don't need to extrude. And then that's going to create an error with our fillet. We can just tap the delete key to delete that out of the timeline once we click on highlight it. So now we have our latest design, which should trim off a good bit of the fat of the older design here. So I'm going to go ahead and pop into Simplify 3D since I already have the STL saved proper cooking show fashion. So we have stripped out just shy of 30 grams worth of filament. So that's quite a bit of savings there. Now obviously I could tweak the infill. Right now I have it about 18%. I could test like a lower amount, like say 15. Let's see what that gets us. So we're about 137-ish. And now we are at 128. So obviously I'm going to test and tweak this a heck of a lot more just because I want to try to get this down as much as possible. Now of course I could do like a small little hole, maybe like a weird shaped hole in the middle just to cut out and relieve some more dimensions, as well as just maybe making some relief cuts around the perimeter, or this inner perimeter here of the circle. What I'm going to do here first is I'm going to make a couple of circles. So we'll just use our standard circle tool, which is just the C key, and I'm going to plot out some reliefs. I don't want to obviously ruin the structural integrity of this said model. Yeah, that should be more than enough there. So I'm going to do 3/8 both in and out. All right, so we are back in action here. So what I have essentially done is I've made more or less a cutout. So we're going to have cut out these areas here and have these little support slots to support everything in. We'll go ahead and go to our initial extrude, take out these bad boys. And another thing I may do is I may widen this bottom path here just a little bit. Yep, screwed up on my math here. It's supposed to be 1/2 inch instead of 3/8 inch. I'm just gonna add that circle in because I don't like how these walls are a 1/16 inch. It's a little too thin. It's fine for this portion just because the center is filled in, but the other side, not so much. So we'll go back, we'll add these features back in. So there we go. Now we have pretty much the maximum amount of stripped out of these things here. Okay, so we have taken a weird turn. So apparently this particular design, the way we have the perimeters set up, it looks like it's going to actually consume more filament with this particular setup here. So we definitely messed something up here. I'm thinking more than likely these walls are a little too thin, so I'm going to try to widen them up. I think right now they're about a 1/16 of an inch if I'm not mistaken. Let's go ahead and just check that real quick. Yeah, that's a 1/16 of an inch. So I'm going to go ahead and go back to our drawing board here. So I figured out a weird issue when you are using fractional inches. Say you want to edit a value, you double click on the value when you're in sketch mode. The way it handles fractional inches is a little odd. So if you just type in 6/8 and then like the inch mark, it'll usually go to red, as I'll show you here. Now that would obviously be 3/4. So what you want to do is parenthesize that and then multiply that by 1. It's a little weird, it's a little redundant, but I guess it's just the way Fusion 360 sees things. So yeah, I just want to change that to 3/4 instead of 7/8 so I can get that full 1/8 inch border, which that should, in theory, give us a bit more meat, and the infill should be a bit more sparse on the inside edge there. So I'm gonna go ahead and save, and I'll get back to Simplify 3D, and let's see if that makes any improvements on our savings of plastic here. I think we might have increased the amount of plastic used by making that change. I thought that maybe setting this outer infill to be a bit more sparse by making that a bit wider, which it should technically be, would help things out, but apparently it did not do squat. So we back to the drawing board on this one. I think I know just a quick little hack to get this to where I needed to be. Got our new design up and rolling here. Now what I did was I reduced the outer diameter of these two circle edges here to 3/4 instead of 1 inch. So that's probably gonna be the most optimal solution for this particular design here. Now I could make this part a little smaller, but I don't know. I don't think that'll be the best idea, especially given that this is supposed to just be a spacer, and it might not give the best support for the actual board itself, because obviously that material, it needs like a big surface area to lay out on in order to be supported. So I don't want to reduce it too much. So I think this is 3/4 of an inch is pretty optimal. It's yeah, you still got a fair bit of meat on her, so you shouldn't have any issue whatsoever with the actual material or the surface area there. So I'm gonna go ahead and export this bad boy. Alright, so we're good to go here. Now the original design, the square design, that took about a little around 8 hours or so for time here. And this one in particular takes 4 hours and 30 minutes. I think the second design we did, which was this but a little wider, it was about 6 hours or so. And this is about 4.5 hours. So definitely quite a bit of reduction in time, which is really good. Now the weight, that is staggering. That right there is that's pretty close to about half of the original values here. So obviously I could probably like maybe on the side of like the middle poke a hole and just reduce it even further, but that would I don't know, look kind of weird, and I think it would create some other printing issues, and doing like relief cuts in the middle of like a solid mass isn't always the best idea, especially if you're just cutting off like a small amount, and the most of that would just be like sparse infill anyway. And if you're to do it like this and it just turns into like a more concentrated infill, that definitely is to our detriment. But this particular design, it kind of goes under the keep it simple, stupid kind of format of design. So I'm pretty happy how this comes out. This is definitely a keeper of design. Obviously, when I print it, I'm going to group all these as tightly together as possible. This is non-optimal. With this design, I can stagger them and definitely get everything super duper close to each other. And I'm really impressed with that print time. Like I said, we've almost half the print time and the mass of the materials. So that right there is pretty satisfying. But that's going to be about it for today's video. I hope you all liked it. If you did like this video, and you want to see other videos like this in the future, leave a like, comment, subscribe, all that good jazz, and have a great day.